Great. So thank you guys. Thank you, Cassie, for this opportunity. Welcome everyone that is here in the place as well. It's really good return for this crazy 2 years of lockdown and finally be able to see people face to face in the security conference around the world. It's really good. So basic question from the lockdown time. Are you guys able to hear me in online? So please provide me a feedback if everything is okay. So Cassie, can you put the okay, I needed to share, correct? Hold on a second. Let me share my screen. And yay. Just confirm if you guys can see my screen. Yep. So my name is Rener Alberto, right? I have 15 years with experience based with penetration testing. I have worked with consultant for many years, right? I am in the conference for developers, so I am not a developer, so sorry for that. But I would like to share some experience from nice stuff that you guys, as developers, you guys can implement in the process to deliver better quality in the final products that you guys are delivering, right? And part of this is the automation of some parts that can be done in the pen tests, right? I will start here. I have my one small agenda about this topic. So yeah, a little bit about myself here. As I mentioned, I have the chance to speak in some security conference around the world, right? Have also the chance to work with some specific companies, and have also the chance to speak a lot of conference like Hackers to Hackers, Alligator, or WASP, besides and others. But come on, it's definitely not important. Let's go for what matter, right? So our agenda, basically, I will speak a little bit about what you guys can automate during the penetration testing, right? I will suggest some tools to do that automation, like present my personal workflow, how I am implementing this, how I am doing this while delivering this kind of stuff. I am responsible for doing red team campaigns and here in ABB. So I will explain you a little bit of this mindset, how we can introduce this mindset of red team in the automation in order to have better results, in order to aim at the focus about what you really need to check and what you really need to exploit. And also, if we have time, automation regarding the reports as well. Okay, so what we can automate and what you definitely should not automate during the penetration test, right? So penetration test, the first phase of common phase in the penetration test, you needed to gain information. So all the gaining information process, you can automate and without problem, but you definitely should not automate the exploitation, right? Because if you try to automate the exploitation, for sure you're gonna land in the denial of service. You started to broke stuff, servers will stop, and it's definitely not a recommendation. So open source intelligence, it's totally fine to automate enumeration. And for the privilege escalation, we have one part inside of the privilege escalation, which is the enumeration. I mean, which kind of configurations we can do exploit, or misconfigurations we can exploit while doing the privilege escalation. This part of enumeration is okay, but definitely nothing related with exploitation, okay? So let's speak about some tools, right? And this first part is just recommendation of some tools. From OSINT, I will try to be more focused in open source tools, right? Because you guys will be able to use that in the companies without problems, right? So we have Spider Food, even Shodan, you have a limited license that you can use to do that. Of course, Shodan, you have one paid license that will be better to grab information about the targets, right? Port scans tools to detect which kind of ports your server is running, what it's exposed. So Nmap and Mesiscan. Mesiscan is really good to cover a lot of range when we have too many machines that we need to cover. So Mesiscan is really good. Then we have another category, which is the network and scans and or host enumeration, which is basically when we land in the network, sometimes we need to enumerate how many devices we have alive on that network. So Nmap, once again, can help you with this mission to enumerate and see how many machines we have on that network. Mesiscan, once again. And then we have really good tools. Greenbone, previously it was known as OpenVAS. We have Nessus, but Nessus is a paid. Qualys, also a paid solution, right? And we have very basic stuff that is very simple to automate the analysis, like SSL, checking the quality of the SSL certification, certificates SSL, and so on. So even Burp Suite has one specific plugin for that. And we have some protocols. SNMP protocol, for example, it's very common in the network, right? So we have some tools like Patato, SNMP check, SNMP bulwark. Even Metaxploit has a lot of tools for this purpose, right? So let me just update the laser here to make it easy. Some other protocols, because nowadays we are dealing a lot with web, right? But we still having companies that are running on-premises stuff, and sometimes we land in a network that we still have in on-premise. So RPC protocol is a very common protocol for Microsoft solutions. So we have some tools that are easy to be automated. And we have for Impact Python library, which is a really good library, which provides to the. And for SMB, some companies you are able to hack the entire company only looking for SMB shares. It's amazing how some companies are not able to protect the basic for SMB. Sometimes one dev would like to share something with another dev, and they put this in an open share folder in his machine. So just share the folder and maybe forgot it's supposed to be temporary folder or someone. And this kind of stuff, the guys that are inside the company to hack the company or doing penetration tests can use this, and automate this kind of analysis very easy as well. So we have Nmap and NSA scripts, SMB client, SMB map, some samples of tools that are simple to implement. Some protocols, remote protocols, we are dev. Usually we use SSH, for example, to connect on the servers and automate, start something, run, deploy something, and so on. So SSH, we have some brute force for that, very easy to do as well. And for HTTPS protocol, we have lots of tools. Okay, so let me just jump for something more interesting, right? When you started to put all this thing together to automate, right? So I am not a dev, but I create my very simple and small algorithm to automate my daily tasks, activities in terms of penetration test. When we are speaking about automation, the first thing that we must be careful is don't create denial of service, right? So you should limit the amount of scans you are running against your server. Because it's very simple. When you started to detect this stuff, you started to call the other tools, you will have a lot of scans, a lot of tasks to run. And these tasks, if you started to run these at the same time, of course, you will create a denial of service in the target machine and also in your own machine, right? So it's good you create priorities, right? Because some protocols or some kind of tools, you should to create one high priority list for this, right? And then you started to segregate what you should to evaluate first. In this case here, I took one screenshot from that when I was running one scan for one, I was doing a MBA course. In this course, I have some CTF challenge where I needed to hack some machines. So I took some samples here and I used this algorithm on this CTF to deliver me the reports and report the vulnerabilities and so on. Here we have a general workflow, right? And how these tools are integrated with each other, right? So it doesn't matter you have a lot of tools if you are not able to orchestrate this tool and use this tool with the correct purpose, right? When you are doing something automated. So this is a general vision of the workflow. And I started creating these as small scripts. So this was my original project when I started to write that. So small scripts to automate some parts. So for example, I want to automate the port enumeration. I want to automate the part of web scans to check how many vulnerabilities I have and so on, so on. This kind of stuff could be implemented for anything else, even for code review analysis. If you have one tool which has one API, you can use that. So let's go into details here about this workflow automation, right? So when the process starts, usually considering that I just land in one network, I have no idea how many machines I have on this network. So the first step is enumerate how many machines I have, how many machines I need to attack, and try to become administrator inside this network, right? So you start with basically host discovery techniques, right? So you can send a ping, this is the basic way to detect how many machines we have alive inside the network. But nowadays, firewalls are blocking ICMP package by default, right? So ping package by default is gonna be blocked. So what we can do, we can use a simple Nmap scene scan, and this scan, you will check and try to connect from specific ports, like common service ports, right? I have one suggestion for ports, so I will try to speed up here, and then we go for the details to when we have more time, okay? So once you detect it and you discover the live hosts, you have, at least myself, I'm using two approaches, right? One and alive. So for example, sometimes we land in one network, we have 2,000 machines inside this network, inside this domain, right, to evaluate. Okay, what I should do first, how I will prioritize, how many machines of these machines are we really scan? Considering that when we are doing a penetration test project, we have a very limited time, maybe 1 week to cover as much you can, hack as much you can, and deliver your report in the end of the day. For this reason, we need automation, right? So speaking about Nmap, I have one very simple sample here. Hold on a second. Let me just. This is a very simple sample, right? So here in Nmap, you have this. Let me just zoom in, okay? So what are these port numbers? So here I started to define with how many ports I would like to evaluate, right? And how I select this port and why I am doing like that, right? Because Nmap, you can simple use one tag like -p dash, and Nmap will cover all 65,000 ports of the TCP protocol. However, it could take 2 days only to run a port scan for one single machine, depending on the network. And also, it will create too much noise that most probably the blue team will detect you, block you, and you will not be able to deliver nothing, right? So how I land with these port numbers, how I took these port numbers and why I am defining these port numbers. What I did was very simple. I go for exploit database, right, which is a website where it usually has a lot of a collection from exploits, very normal in the security industry. I also go for MITRE, right, for CVEs and so on, extract out the ports that were related inside the source code. So I go for the source code for every single exploit and extract the ports that were there. I did the same for Metaxploit. So then I compile all the port in this list, okay? And why I did that? I don't need to check 65,000 ports. I needed to check ports that most probably have vulnerabilities related with that product running behind of that port, right? Because usually people don't change the default ports. So this is my first advice, change the default ports if possible, right? For some stuff, of course, we cannot change. For web servers, for example, you need 443, we need 80 sometimes, you know? But these ports are my focus to bring that. And for this reason, I am commenting about that. So returning to this, of course, after that, if I have time, I will also check all the other ports. And Nmap will give you one report, right? And this report could be easily automated about what you will do next with the information that you come here. Here is a simple sample of an Nmap report, right? It's showing which port it's open and so on. So Nmap has a lot of scripts that could help you to identify the vulnerabilities, right? So here it's a very simple sample about that. So for example, this model here from Nmap, it's looking for comments inside the source code. It's very common, actually, we find comments inside the source code that could help us to exploit something, okay? So based on this, basically parsing this result, right? Parsing this result, we can define what we will do later, right? So basically filter what is networking protocols running and what is web protocol running, right? And down here, we have some samples of the stuff that I started to automate on that time. SNMP, brute force, RPC protocol. These are kind of protocols that usually people that are dev, they don't really understand how these protocols are working. But I can tell you, these protocols, if they are open, they could leak a lot of information for who is attacking, right? And SMB, three basic protocols that most probably remain open because by default people don't pay attention to these protocols, and we have a lot of actions that can be done against that. Let's speak a little bit about web, right? Which maybe is the part that is more familiar with the majority of the people. Some analysis in web, at least run something, right? Run some scan against your own website or against your own app application to see how many vulnerabilities you have on that before you deliver. It could give you good insights about security in terms of that. So basically, a part of that, I apply one spidering. Spidering, you also call it crawling. It's a process for navigate for every single link we have in the application, right? Because it started to map in the application, it started to create one map about that. So spidering is that process, right? So then we start to run the tools, right? Sample of tools, Burp Suite. Burp Suite is lead in the market nowadays, one of the leads of the market nowadays from vulnerability analysis and vulnerability scans. The result for Burp Suite scan is really good. Of course, Burp Suite is a paid license, but it has one API, and you can use this API to run the scans, receive the result. CMSIC, it's one tool that will help you like consider that you are a pen tester, right? Or something like that. It will help identify vulnerabilities for CMS because nowadays companies are using a lot of CMS, and this process of automation will help you. For example, WordPress, we have one specific WordPress tool inside Kali Linux, which could help you to identify a lot of vulnerabilities in WordPress. So all these other tools here are Wapitis are open source, Arakin are open source, and we have some process of fuzzing in the the HTTP protocol to identify sensitive files. I have some samples of that here in this presentation. Eyewitness is a very interesting tool because it's automation of a screenshot. And then we say, why I will like to automate the screenshots from the websites? Because consider that you have, for example, you map the network and you have 3,000 websites to evaluate or 3,000 URLs to evaluate. When you automate the process of the screenshot, you can quickly see small pictures about what is running on that. And for example, only using this process, sometimes the developers receive one server to do the job. But for example, directory listing was, for some reason that I still not understand it, sometimes the people enable directory listing. It means that everything inside that folder will be exposed, right? So when you start automating the process of a screenshot, you can quickly see maybe, hey, this is a form, so I should focus more effort to try to hack this form, like a login page or something like that. That's most probability to have common vulnerabilities, like, for example, SQL injection. Okay. Tesseract, I will speak specific about that because it's what else I am doing with screenshot. Another tool that I would like to suggest is Nuclei. We have a lot of vulnerabilities that was very famous, right? Spring for Shell, Shell Shock, a Log4j, and so on and so on. All of this, we have CVEs for that, right? So Nuclei has a database which all of these CVEs, and you can run and quickly receive the result and check if your application or your server is vulnerable for any of that CVEs. So quickly you can identify what you are vulnerable with that. What I did was, okay, I found the CVE, so I searched for exploits related with that CVEs. Because remember, we still have in Mitre, we still have in Metaxploit, we still have in ExploitDB. So just deliver to me, this is the CVE, okay, here is the vulnerability, and this is exploit. I just take the exploit and get inside. So this was the general overview about that. So how we can apply the red team mindset on this automated process when we do this level of automation, right? So due to the limitations here, I was not able to run everything automatically because I would like to do this live for you. But we have some limitations here. So I decided to take the screenshots and put this and explain what's going on, okay? So this is the basic sample, right? This was a CTF, by the way. So it's real products, real scenarios, but in the CTF, so it's a controlled way, right? So here we have one login page, right? Very simple login page. What is the problem here? When you put the name of your product in this, like in the bottle we have, and we have eyes of network. So we have this here and this here. It's easy for who is attacking, go for this database and searching for vulnerabilities related with that. The process, and usually what we start with the enumeration of how many ports we have open for that, right? Okay, so basically this is the report for Nmap. Do you remember that we have inside Nmap some scripts to detect comments? So here we can see the comment that was inserted inside of that, which is also leaking the version. This is a gold mine for who is attacking you. Don't include version inside the comments, and avoid include version inside anything that could be exposed. So what I did, basically, based on the open ports, so I have these ports open, right, in Nmap. So what is the mindset? Sometimes we could detect some ports that are not common ports, right? In this case, for example, I am using a not good sample here because it's 3306. We know by experience who is developing know that MySQL is running on that, right? So basically, every time I take one port that are not 80.443, I go to this database, research how many exploits that we have, and create this list. So this is an automated list that my algorithm is given to me. Then I will have every single exploit related with that port. Why? Because sometimes people are trying to protect themselves. The port is open, but we don't have banners, we don't have version exposed, but the port is still there. If it's a default port, I'm still being able to detect what is the product, right? So in the right side here, we have some ports that are related with this detail, right? Some this port here in this case is 5,000, so I have no idea what is could be running behind a 5,000 port. So then now I have one idea. Which kind of products usually use this port, and how many of them we have vulnerabilities, right? So when quickly can identify with this approach. How it happens if I supposed to do it manually, right? I supposed to take this information, go for exploit database. This is the website, search for this product, and then I will have the list, right? So this process was automated, right? I have this list of everything related with that software. Sometimes we don't have this inside the source code, inside comments or something like that. So then we need to use a different approach. You remember, I automated the process of screenshots, right? So here we have all the screenshots in the bottom here, all the screenshots that was taken by the application, by the form of the application, all the screenshots. And then I have two tools on that list that I presented you before, which is Eye of Witness, used to take a screenshot, and Tesseract. Tesseract basically will apply OCR in the image of the screenshot image. Then I can extract from this image every single word I have. Because these eyes of network we have in the top here, in this part here, this is an image, it's not a text. So I supposed to not detect this product by evaluating the source code because it's an image, right? It's not right in there, but it's in the image. So I take a screenshot, convert this in OCR, and now I have the name of the product as the same way. Based on that, I will extract every single word from this image. And now let's research again. Let's see how many exploits we have again about that, right? So here we see, of course, everything will bring you false positives. And here we have a good sample of false positive because I was checking for the word eyes, and it came with me with one product called Web Eyes Guest Book. It's not this case, right? But here we have Eyes of Network is exactly the same product, which was exposed there. So now I know exactly how many vulnerabilities, how many possible exploits we have for this product, right? Just one simple stuff. What you do, you just put the name of the product in an index page. And it could be used for who is attacking to detect vulnerabilities against that. The same happens when we are using a library. If you are using one library in your code, even a stupid JavaScript library, if this library are not receiving updates anymore, your code will irritate this vulnerability, right? We have, for example, Black Duck, which is one tool that could be used to automate this process, which will evaluate how many commits this library is using. It's still under development or not. So there's a lot of stuff that could be automated in this process. Okay. So, Cassio, does we have any question online or something? Okay. So guys, is it okay? I mean, it's fine to, it's very simple, the process, right? So it's automation, it's, okay. So another sample here, but in this time, this word eyes of network was extracted from this, and the same scenario here, but this time more accurate, right? So very simple sample about that. And I am telling you one history about how we hack this machine, right? This machine. This is machine that we are hacking. And I will show you the process of hacking this machine step by step, okay? So it was a simple product, right? We found very quickly, we found possible exploits for that. And all the exploits here, if we read, we need one credential, right? Are exploits that are affecting that product, but only if you are authenticated. So at this point, it means nothing because we don't have credentials on that, right? Okay, so another port that was open in this case was the port 5000. Okay, so let's do the basic analysis on that. And this led me to the web fuzzing, right? What is the process of web fuzzing? Web fuzzing basically, or brute force for sensitive files, right? So we can use a word list. We have a word list available on the internet, right? This is what the attackers will do. They will take this word list and use this word list and looking for these possible sensitive files inside your server. If they found something, and how it works, because the HTTP protocol, if you request some file, if this file exists, it will return HTTP 200 for you, right? If it don't exist, maybe 404 or something like that. If its access is necessary, 401. So this is the base for HTTP protocol, right? So using this behavior of the HTTP protocol, it's possible to find sensitive files inside your server, right? Like, for example, backup of the API. When the guys did one backup from the API, if this backup remain in the same server, yes, they can easily find that with this process. However, this is one step behind I execute the process by itself. What I do is map what is the behavior of the web server, right? How I do that? With wfuzz, I started to sending, looks like that I am sending trash, correct? But there is a logic here in this trash. It will be randomic text, of course. But look, here I am checking what is the behavior when I try to access some PHP file. Most probably, this PHP file don't exist, but I am looking for what will be the behavior of the server, right? So, and then I evaluate how many words it returning in the sample, in the HTTP body, right? How many words I have there? How many lines? So what is the behavior of the server? So for example, every time I send something like that, I have 51 words on that. Files that don't exist, 31. So after map, and also we'll try to put something like, for example, let's put some words inside of that. Put log on page, admin, something in the middle, and see what is the behavior of that. And why I do that? To avoid false positives. Because the server could be configured by the administrators or by the developer team to always give you like fake response, right? If it are programmed to provide fake response in the HTTP protocol, or for example, they have one WAF protecting, this WAF will always give you. So by mapping the behavior before I do this, I can really mapping what I am doing. So then I will run again the wfuzz to enumerate that, but this time I am mapping and putting here what they supposed to hide. Hide all these words. I mean, every single time I have one answer that have this number of words, hide this because it's a false positive for me. Then I have exactly precise result here. No false positives. In this scenario, remember, we are speaking about a CTF exercise here in ABB, so for this UDF sample here. So I have two files, user.txt and one file called secreto, because it's a Portuguese CTF, by the way. And for this reason, we have its basic secret. Then the parts that you cannot automate it, which is the hands-on, right? Some parts from penetration tests, it could be automated. Until this point, everything was automated. Now we needed to do the manual job, right? So I needed to evaluate this secreto file. So basically, let's try to access this. Very simple stuff. Okay, it's something to be downloaded. Downloaded, and I have a weird text inside of that. Secreto was a zip file, but at this moment, I have no clue about that, right? This file was a zip file. And here I was trying to identify, I have this Unmask It online tool. It's a really good tool. Every time we receive some, because nowadays the guys are trying to encode and encrypt as well the malicious code, right? So this website help you to decrypt that. So I was just checking, oh, let me see what we have here. Nothing in this case. So let's move on because I was not able to receive nothing here. So I was checking this file in the details. So here on the right side, we have the details. And on the left side, I put one magic, a magic number tables, right? Because every single file, the first 2 bytes of this file will tell which kind of file is that. And I evaluated that this file, it has a break of line. So I put all together and tried to decrypt that using base 64. For my surprise, yes, it was a base 64. And you guys can see this on this part over here, right? So base 64, and I can see credits.txt and something else. So for me, when I look for that, by the experience, I know this is a zip file because of the magic file number, which is PK, right? So if I do one basically X evaluation of this file, I can see this PK file, and I just put side by side here how I got the conclusion that I was speaking about a zip file here. And actually, what happened in the context of this, the guys put one backup inside of that, and they tried to use one name that was not common and remove the extension for this file to not be easy to detect this file there, and leave the backup inside of that. And okay, now I find this, and let's see what we were able to do with this file. When I try to open the file, because I see creds inside that, okay, let me check which kind of credentials, maybe someone saved this file. And surprise, surprise, this zip file was protected, right? All of this is hands-on. What I did before was automated. Now it's hands-on, okay? And okay, it's a normal zip file protected. So what I did, I automated the process of brute forcing of this zip file, because let's use automation as much we can, right? So then here is the kind of the simple script code that I use to brute force that. I'm using John the Reaper John the Reaper is a really good tool to create modification in word lists, right? So we have a word list, and we try to use this word list more kind of human password. So John the Reaper can do that, right? So I use HawkU, which is a really good word list, by the way. And then I use 7-zip to test the password, right? So try to zip that with this stuff. Cassio, we have questions? Mm-hmm. It's taken care by automation, right? But I just create a simple script for WFUS to hide this false positive stuff. So yes, this is provided automated by for the tool. Everything I showed before, it's automated, and now I am showing what I mean. Everything, every time that I have something automated, I will put in the top automated. When we have something that is hands-on, you guys will see in the top of this slide, like hands-on, right? So this part was automated, and I found the password for the zip file because it was a weak password file, right? And was inside one word list. Okay, now we have credentials, right? Let's return for the website, which we found at the beginning. And now, hands-on again, we try to access this. So we were able to open the zip file, open the text file, and voila. We were able to log on in Eyes of Network application. Eyes of Network applications is one tool to be used inside the network to automate some process in terms of maintenance and so on, and also security scans. This product tried to do something. And by the way, I was connected as administrator on this tool. And here we have the real version of that. So the comments that we saw inside the Nmap comment. It was wrong, and now we have the real one. So we already have all the exploits for that, right? Because now we have the version. So I just select the correct exploit to use. And one of these exploits basically was telling me that I am able to abuse on one functionality of this tool, because we have one field here where we will, because this tool, this eyes of network, you can use this to map your network. And it uses Nmap. And we have one field here where we supposed to type the IP range, correct? However, this IP range will be executed by Nmap. And Nmap, to do some stuff, it's common Nmap requires root access or administrator access to deal with the kernel, to be able to manipulate the network, the network card, and send more packets than the usual, and so on. So yes, Nmap sometimes could require root for some flags. So it means that Nmap is being executed in the background by this tool as root. So how I use that to escalate my privilege? I simple, instead of put only the range. So I started this is my payload, right? So the ports, and I started to put more Linux command. You see, I just put semicolon, echo, and then I started to create my own payload. This payload here, by the way, is my shell code, is my command to lead this machine to connect on me. On left, I open this port 443, right? And put this unlisted in my attacker machine. Preparing this, I'm using netcat here, preparing this to receive this connection. In Linux, if you do that, like using /dev/tcp, and you put the IP address in the port, it will connect. In this case, sorry, there's an error here because I use 80 port, and in the slide it's 443. But you guys are understanding the idea. And then I insert this malicious command here and execute. And Nmap connect on me when the tool was running that. Nmap was running as root. I receive the reverse shell on the left side here, step 3. I receive the shell as root. So yes, this system is fully compromised because of what? One error in the web application, in the product, has one simple parameter that was executed by the operating system. It led me to execute remote code execution in the operating system. And this guy simple expose one version. Simple like that. Stuff that are common, and nowadays it's something very, very common to do. One more case here, a different target this time. So for automated, so we have a very simple web page, only 2 ports open, which was 21 FTP and 80, right? Only 2 ports open. And here we have the result of other automation. So to spidering, I'm using Go Spider to automate the process of crawling and so on, and have one map of everything, every single URL here that we have HTTP 200, which replied me with HTTP 200. So then you remember that once identified, I will automate the scans. So this is the Burp Suite API result scan here. So all the findings and so on. And for my surprise, for some reason, Burp Suite was not able to find one command injection, because we were going to see that this parameter here is vulnerable for command execution. Command injection, right? So I am able to remote code execution on that. And what found this for me was Wapiti, right? He found me, hey, there is one code execution here. And here we have the parameter. The name of the parameter is buscar. It's written in Portuguese. So this parameter is vulnerable. And here is the proof of concept. So I already have in my hand the vulnerability and the proof of concept. If I am a pen tester, just put this in the report. Well done. You finish your job. But I am a red teamer, so I needed to go there and exploit that, right? So very simple, and this is crazy stupid stuff. And also we have other tools that also detect the same vulnerability for me, which is Arachne. Arachne is a really good tool, but unfortunately, the developer for this tool stopped to update this tool. But it's go very, very deep in the web application and really good analysis. So it also detected here operating system comments. It was able to execute operating system comment on that. So 2 tools identify that. Okay, so let's try that. Oh, simple like that. I just include some operating system comments and it was executed by the web application. This is the result for very poor PHP code, like PHP code that was not good enough. I mean, the guy don't even use a simple framework because this kind of stuff nowadays is stupid, right? You find that this kind of remote code execution nowadays is stupid because the majority of security frameworks are blocking that. So please review your code, run some remote code analysis in your code, even if it's a simple PHP application, but please do that. So here is the proof of concept that yes, I am able to execute commands in the operating system. So very stupid. So I was thinking, okay, maybe this machine will be tricky because in CTF, when you get inside the machine very easy, the exploitation to become root use it to be more difficult, right? So evaluating that, what I did, once again, let's prepare to receive a reverse shell. So here I put my port and listening, right? And using one module, I create one web server, right? I create one web server and I create a very simple PHP file, which is a reverse shell, right? A malicious PHP. If I be able to put this malicious PHP inside the server, I will be able to have access on that. Then I injected this command over here using wget, right? And commanding the system to go for my server and download this file that I create, right? This could be also be done, okay, but I'm having here Linux commands and Linux sample, but it can be easily done if you are running Microsoft server as well. It's kind of the same. So here's just the proof that the server came to me, downloaded this file, right? After this file is downloaded, I am able to execute commands on that. So what I need to do, simple, prepare myself to receive this reverse shell, reverse connection, right? So using netcat here. And once again, this is hands-on because this is exploitation. So don't automate exploitation because it's very dangerous to try to automate that. But this is a hands-on. I prepare to receive the reverse shell and just access this in the browser. When I access this in the browser, here you guys can see the results. The server connect on me because my malicious PHP code was executed inside of that. Okay, so and inside of this, I found the first flag of the CTF challenge. And okay, let's check what we have inside. A simple analysis on that, and I see that, okay, we have a backup here. I try to hide the backup, put in one dot before of the file. So it is the way to hide files inside the Windows. And yes, we have one backup. I was evaluating this backup and voila, hard-coded credentials. So please don't hard-coded credentials, even in a simple website. And this is kind of the database code credentials, right? The database credentials. And now I have on my hand one possible user, right? Which was desafio02 and one password. What I did, I just checked in /etc password to see if this is a valid user in the operating system. And yes, it was a valid user in the operating system. And then I was checking, okay, let me see if I can use this credential, right? Because I am in the system, but I'm not using this credential. Let me see if I'm able to access this credential. And here, for my surprise, we have one port 22 open. But if you remember, Nmap showed me only 21 and 80. It means what? We have a firewall. Yes, thanks for telling that. Yes, we have a firewall blocking here, right? So we have a firewall. So let's see how to bypass this firewall, okay? But before that, I was testing this credential where in the FTP because FTP is open. So let's try to access that. And yes, I was able to access the FTP with that credential. So but I was not able to access the root directory because this guy doesn't have the root privilege for this, okay? And moving on this was the scenario, right? We have one SSH service running inside the machine, okay? The web server, which was the port 80, FTP server 21, and these are basically the firewall rules, the representation of the firewall rules that I have on that scenario. So basically incoming, we only have 80 and 21, and this firewall was also blocking the output. I was able to go only outside from this machine only for 443. Very common firewall rules, so a good firewall in general, because it was blocking, only exposing the service they were expecting. Okay, so it means that I am not able to connect on that SSH. So they are safe, right? No, they are not safe. So chisel is one tool I just put here, so not become so boring. So I just put the codes here, and I mean we will land these slides for you guys later. So are 4 steps that we can bypass this firewall using chisel, right? So the first step is send chisel. Chisel is on binary, written in Golang. And I send this for this machine as the same way that I send my malicious PHP file, right? I just send this to inside the machine. Inside the machine, I execute chisel, right? On this target machine. I execute chisel first on my machine, creating the server, and then I execute this in the target machine as client. So the result of this, just to speed up because I take too much time, will be this. So step 1, in the adversary machine, I run chisel as server, right? After send the chisel to the target machine, I command the target machine to connect on me on my port in 443, right? Because it's the only rule that I can access. It's 443 as output. In the target machine, it will open the port 9001. I tell chisel, hey, use this port as SOX port, as SOX 5 port proxy. And then I convert also the port that chisel will open on my side in SOX proxy. So I will have one port, in this case, 1080. Every single package I send to this port, I will land in the opposite side. So now I am able to access the SSH. How to force my network packets to go to inside? Proxy chains, right? We can use the proxy chains and say, hey, everything that I run using proxy chains, send the network traffic to this port. Then I use proxy chains, SSH, right? Then the credentials that we got, because we already have these credentials, right? We found this inside the backup on port 22. All this traffic will be routed as described here, right? Using the 443. So one port that was using only for output, remember, TCP protocol, it can receive and send data. So firewall are not protecting you. Okay, firewall is not protecting you. So then now we are able to access the credential as this guy. And this was a funny because this guy has permission to run Docker containers. Very common for developers nowadays, right? Sometimes the company don't give you the root or the administrator on the machine, but they allow you, in this case, this was the scenario, they allow you run Docker containers, and they will set up the operating system, granted the root privilege only for Docker process, right? So you as user, you don't have the administrator or root privilege, but the Docker has. In this case, it's not Docker because they are using LXD. It's very similar to Docker, but it's a more native Linux virtualization. 5 minutes? Okay, I'm finished. And then what I discovered, I can create one malicious image, right? A simple Docker image, send to this file, because if you see here, I was listing the image, and there is no image there. So, okay, this guy received the access, but he removed the Docker image that he has. So I create one very simple one using Alpine. Send these files, these 2 files to this machine, and I just using SCP to copy this using the bypass of the file we have. Send this to the server. So here are the servers, right? The files inside the server. And now I am able to run this machine. So I installed that in the local machine. So now I have a simple Alpine image on that. Until this moment, nothing is different. Is I just set up that this container will run as privilege, right? So when I run this container as privilege, I can mount the root slash the root directory, this slash directory inside the container, and I was able to access that. So basically, when I started this container mounting on this directory, everything inside of that, including the root directory, remember, we are not root, but now we are having access to everything. Even the slash etc passwd, we can crack this password and have access to that. So a lot of this process from automation, I have other samples here, but unfortunately I take more time than I was expecting for that. So I will open for some questions for you guys, especially for who is online and so on. And I hope that this process, I mean, this speak about automation, I mean, could help you guys to automate your own process, right? To do that. I just give some insights here that can be used and how these simple actions help me to do that. For how many minutes, Casio? Just show you one report sample. Okay, it's gonna be very quickly. Hold on a second. Let me. Mm-hmm. So the only part of this that I was missing was automation of reports. So this is a very simple report that I generated using one tool called Serpico. So this is kind of the level of report that we have from that. This is kind of the CTF flag what I have there. So once I have, so here my name, it's written in Portuguese, sorry, because it was a CTF for people in Brazil. So this executive summary part of that, all of these you can automate the process to generate this report. The scope of the project by itself, all of this, because usually this kind of text will not change too much, right? So you can kind of have this. The scope, what was the IP address of so on? In this case, is a CTF stuff. One table with all the vulnerabilities, right? Could be automated by this tool. It's really useful when you need to do this kind of job routinely, and you need to deliver that. The only part that is not automated here is this graphic. I created this graphic by myself before deliver the report. So this is executive summary, and then we go for the technical part of this report. All of these you can basically create templates, right? And what really changed in this report are the vulnerabilities by itself. So here we have the vulnerabilities, the critical level, the description of the vulnerabilities, and so on. And you remember the screenshots and everything that we got automatically. So then just put the screenshots here and so on. All the CVEs that was detected, automated by the scan, I just put this here. So the process of creation of the report, it's much more fast and then report everything again. So all this WFuzz stuff you guys see before, this is a different machine, a different attack. So, and then all the process of exploitation, how we were able to abuse on SMB protocol and so on. All of these screenshots, everything like that was automated, including the generation of reports. So Serpico is a really good tool for automated reports. Guys, I hopefully that this message could explain you how these processes are automated nowadays and why I'm telling that. Ransomware groups are doing this to get inside companies, hack everything, compromise everything, and the majority of the time is automated, right? I am not a developer, and I was able to automate at this level, right? So if I have the experience that you guys has automating, right, and apply this malicious knowledge to create something like that, yes, you guys has the probability to create something much better than this, right? So I hope you guys enjoy. It's really good to see face after a long time. And here are my contacts on LinkedIn content and so on. I'm not very active on social media, but I will try to answer and accept the guys. I really appreciate the opportunity, Cassio, the organizer, and so on. So, and we're still in touch in the event. Okay, thank you very much.
myself. So please, Paweł, just introduce yourself. So hello, everyone. I'm Pawel Kusiński. So impossible to pronounce for Casio. And today I'm going to talk a little about persistency on serverless. So one of the attack vectors on function as a service. So I think we can start. I won't be boring you with my titles. So what are we going to do today? We are going to achieve persistency on vulnerable Lambda and cloud functions, so GCP and AWS. I will show you a live demo, live exfiltration of the data from the both of them. This method is nearly undetectable after execution. So let's see how it's done. Let's start from some basics. I will explain at the beginning why I even chose this topic. So my main inspiration was Yuval Abrahami, and now I hope I'm pronouncing it right. He's from Unit 42, and he was the first one to deep dive into the topic of serverless. He did this on AWS Lambdas already. So I thought that I will continue his work. Second argument for me was that serverless is really widely used by corporations. A lot of companies are introducing the function as a service into their products or experimenting. So in the nearest years, we'll probably see a lot more of attacks on serverless. For those who don't know what is even a serverless function, it's something where we can upload our code and we don't have to deal with managing the server. So we are only just looking at our code, we are only managing our code. We don't have to worry about deploying it, about securing the environment, etc. So it looks nice, it looks great. But what if there is a vulnerability in our code? What if that vulnerability would be an RCE, remote code execution? And okay, some of you which are into security would probably now say, but Paweł, RCE is so rare that nobody would do this. Why even care? I think we should care because, especially in last years, we've seen a lot of attacks on developers, on package managers. So we've got, for example, typo squatting, dependency confusion, account takeovers of package manager, of libraries, and a lot of stuff where we can just introduce the vulnerable code to one of the packages we are using. Even not so long ago, there was a malicious package in Python libraries, one of the widely used ones, CTX. And funny thing, it was stealing the keys from AWS. So let's go from the start. We've got this beautiful Lambda, which is processing some data, which we are sending. And the processed data is going to be saved on some database, in this case, DynamoDB. Let's say our DevOps or administrator knew how to do his stuff, and he created a role which can only write to DynamoDB. So theoretically, we cannot read the data saved on DynamoDB. But what if we will introduce our exploit into the Lambda itself, or the environment where the Lambda is executed? Then we'll be able to exfiltrate the data live, so we don't need to have an IAM role. We can just read the data. I'm going to cover some topics of serverless infrastructure to get to the core of everything. First thing is a cold start, or also called cold boot. It's a happening. It happens when we first call our Lambda or cloud function. So the first execution is usually really slow because the environment has to be boot up. Okay, that's great. Consecutive calls are faster. Every next call will be executed a lot faster because environment is already up. So our file system probably persists, but it happens it is only frozen between the calls. And at least for me, it was mind-blowing because I thought that serverless functions are like volatile ones. So after the news, we don't have an environment. Why do we need one? It works like that. So we have some user or service which is calling our Lambda. Then the invoke service, the one of the backend AWS services, is looking for the machine to execute our function. Because there isn't one, he calls a Firecracker to set a micro VM, micro virtual machine. Firecracker is a software created by AWS for booting these micro VMs really fast. It, of course, is on sandboxed environment, so it should be secure, not so secure as I will show you. And of course, it executes the Lambda function, which gives us our response. That's the first execution. In case of consecutive calls, the process could be really simplified because invoke service calls Firecracker, which has the machine, so it could be simplified like that. It's really fast. In case of GCP, we've got really similar approach as we will be using also the containers, but this time with gvisor. That's also a security sandbox, so nice. The next thing is something I called control process because I didn't found an official name. So what is that? In case of AWS, our environment, our file system looks like that. So we've got some bootstrap process on the file system, which talks with the init process. Bootstrap is communicating through HTTP with the init, and it wants to get the next call. So he sends the next request and awaiting a response. Slicer is some process outside of our VM. We don't know what it is, but the slicer sends event to the init process, which then sends it to the bootstrap with the invoke ID, which will be important in a moment. The event is then sent to our code, and it is executed, and then response is going back to the init process. And for the process to end, we have to send an invoke ID to init process. With GCP, the whole problem is really simplified, as GCP thought that they can just boot up a web framework. So they are using Flask in case of Python language. In case of other languages, they are using similar web frameworks. So they are just routing all the events to our function. They are just dynamically importing it. Really pretty simple, nothing to comment there. So why persistence is possible in this semi-volatile environment? First thing, really we don't have volatile file system. That's at least some for a few minutes because the file system persists for like 5 to 15 minutes. In case where we'll be pinging the system all the time, the file system will persist for hours. There won't be a need to destroy the first one and to boot up new one. We've got nearly writable file system, as we can access the TMP folder, and we also can access the memory. And what's the interesting one, the control process is inside of our container or micro VM. So let's imagine, in case of AWS, let's send some malicious event to the vulnerable Lambda. Our malicious event, so our payload will boot up a new bootstrap. And now the question for at least offline guys, we have to get invoke ID. Any ideas how? Yeah, there is on the there is invoke ID on the file system, but how we can get it? We aren't root. We have to remember that. Okay, so first thing which comes to mind, when we are part of the process, because we are executing from our Lambda, we can just look at the stack. We can just import inspect library in case of Python, or other alternatives in case of other languages, and search the stack for invoke ID. It will be here. In case of being a sub-process, when Lambda executes our code in another process, we can regex through the memory, through the prods, because we have access here. But there is a really simple method which is undocumented and really funny, because if the last process didn't end, the last bootstrap didn't send back invoke ID, we can just request it again and we'll obtain the same invoke ID again. So init process just going to send us the correct one, and we can end the process with our evil bootstrap. So now we'll have a situation where the old original bootstrap is still waiting for the response in this frozen sad state, and our bootstrap is just communicating with the init process and our server. What about GCP? As I said, there is some dynamic imports, so I thought, why not to use this little monkey, or the process called monkey patching. That's the dynamic override of definition of the function. So we are sending our malicious payload to the vulnerable cloud function, and we are just going to override the routing function to now execute some of our code. So let's go for a demo. In my demo, I will have this piece of code. This is a vulnerable function. So we've got here a vulnerable YAML library with a remote code execution. And I've got backup videos, but let's hope that I will be able to do this live. I don't have duplicate screens, so it's not gonna be easy for me, but let's try. And I've got internet, I hope. Or not. I'm live? Okay. That's funny thing. So maybe let's do a fast reboot. Live demo problems as always. Let's give it a moment, and if there will be still a problem, then we'll go for a video. This is a meme question, I think, from my presentations. I was too lazy to test the Azure functions. I've got this planned for the next month. So I'm not sure how it works in Azure. I can be sure, but I really think it works like that. That's funny thing. I've got one other idea. Wait a second. I hope I won't disappear because probably I have to connect to my VPN to get access to my server. No, life is more emotional. Give me like 1 minute. It will work. You see, like everything not working is nice now interesting. And okay, yeah. Okay, so we have to go with the video because my VPN it cannot connect from guest Wi-Fi here. So sad. So let's say at the right side of my screen there is my own VPS server, which will host the web server for hijacking the events. On the left side, we've got the attacker console, which will be sending the malicious payloads, and normal user, which will be sending some demo data, which will be hijacking. Let's go with that. So if I remember correctly, let's see our YAML. In our YAML, we've got some basic data like name and email, and we are sending it to the Lambda function and getting the success. So everything good. Let's start some listener on our server and create our YAML payload. I will show in the moment how it looks like. This is just a shortcut for creating a YAML file from our payloads. Let's send it, and as we will see, now the response is a little bit longer, that's intentional, and we've got different output. Let's try sending the data again. And after a moment, we can see the data got to our server also. We will also send the second payload to verify the persistency of this malicious payload. And as the last one, we've got our data. So, as you can see, I've created a YAML file from two files, from Switcher and Evil Bootstrap. So let's go into that. We've got this Switcher code, and don't worry, you don't have to read this all right now. We'll go line by line. So at the start, we are just decoding our Evil Bootstrap, which was part of our payload. We have to save it somewhere to be able to execute it. And we can just send it to the TMP folder. But in case if TMP folder would be somehow blocked, you can also create an anonymous file by syscall mmfd and saving the bootstrap just in the RAM memory. It's not a problem. Then we have to obtain our invoke ID. So as I said, we are just creating an HTTP request to the init process. And AWS is a really good guy because URL lib3 is pre-installed on every Python environment. Nice for us. We don't have to go into the sockets. Then we are just executing our new bootstrap. And our whole bootstrap is just a copy of a normal one. The code is on the GitHub, or we can download it from a normal Lambda function. We have to add some lines of the code. So first thing, the main for execution. We have to start the process and send the invoke ID. Then we have this beautiful piece of the code, which you don't have to worry because only this one line matters for us. And this one line, which I added, is just sending the incoming events to our external server. We have just to hard code our IP. And as I said before, we've got our lib. Great. Let's go fast with GCP. The same, what is on the right, on the left side, the same look. We are sending the normal YAM file, creating the evil one, sending it, waiting for execution, starting listener, and now we'll be sending YAML again. Simple as that. So what was the change in the code? Switcher, the same thing. We are just saving it on the file system, and then happens something different, because this time we are monkey patching. So we have to import our saved function, we have to import user function, and we have to do this all dynamically because we are inside of the executed code. So we cannot just use import library. That would be too easy. So we can go into the documentation how import in Python works and copy most of the lines of importing the files, where we have to get the paths for our code. Then we have to load it and import it. So build the modules, append it to the environments, to our sys, and also execute it our namespace to be able to get all of the variables or everything out there. And for all of you which are reading the code, you are probably interested from where I've got this up variable. So because we are part of the process of the original one, we can just import it from the original Flask one. So we are getting the context of the Flask. And because of that, we can overwrite the function. So we are just overwriting it. Simple. And our new evil function is just sending all of the events again to our server. This time GCP was a little bit, I would say, smarter. We don't have URL lib, we don't have requests. We have to go with clear sockets. And that's all. That's all. We are just giving there our exfiltrate data and our little socket implementation. You can do this by yourself. I've uploaded everything to my GitHub. You can set up everything with Terraform. That's like 1 minute, 1 comment, and then send your own payloads. What about the external process? As I was saying, in AWS, that's not a problem because invoke ID could be obtained by creating a HTTP request. In case of GCP, I didn't find any way to do that, because in case of being a part of a process, we can connect to the Flask namespace and overwrite the routing function. In case of being a sub-process, we don't have this possibility, and we don't have any access on the system level to deal with the process memory. We cannot like fuzz it or overwrite it or anything like that. At least for now, I didn't found any way to do that. So GCP is a little bit more secure. Let's go to mitigations and detection. So what do you think? Any ideas how we can secure it? That's interesting. Yeah, that's interesting idea. I've discussed it with few people, but we think that wouldn't be possible because it would limit the possibilities of the functions itself. Because, for example, using the file system is one of the functionalities which cloud providers want to give us. For example, we can use this for optimization for some AI data learning. Like we can save something on the file system and minimize the execution time, where on the function as a service we are paying for execution time. So that's important one. In case of both providers, we can go with our virtual private cloud. So we can just deploy our functions in our own private subnets. We don't have to deploy it publicly. In case of AWS, we can go without NAT gateway, so then the function will be fully private. It won't have connection to the outside world, but also outside world wouldn't be able to connect to our function. So in case of some private data modifications or something like that, like external backend process, that's good enough. That would just work. In case of GCP, we can go with the same thing. So it's called then whole traffic routing and also without NAT gateway. But the problem is when we want our function to be visible publicly. In case of AWS, we can go with implementing security group, or rather configuring security groups to not allow any inbound connections, because security groups are stateful. All incoming connections will also be possible to response, but Lambda won't be able to create a new connections. So implicit deny. In case of GCP, I don't know why, but there we have to create an explicit deny rules. So we have a little bit more problem because it won't work as easy as in AWS, but it's also possible. So we can just, in case of AWS, create rules like that. We can open for inbound, close for outbound. And my little evil bootstrap will just show that connection timeout. The same with GCP. We are creating the deny rules and obtaining timeouts also. But if you think about it, that we have RCE, or for example, comment injection, it is still possible to evade this. Like, we can just modify our evil bootstrap to store all of the events on the file system in the temp folder. And then, like after 10 minutes, we can send new payload, which will read it and set it back in the same connection, evading all of our security group rules. So really, it isn't possible to deploy publicly vulnerable function and make it secure. Or as one of my friends said, we just have to don't deploy vulnerable functions. It's that easy. So how about detection? That's also a funny thing, because it's really hard to do in case of having a vulnerability like that. We can try with creating some alerts based on execution time. As you saw, the execution time of the function in case of our payload was a little bit longer. So when we've got some statistics and we can create some, based on this, how long our function executes normally, then probably we could create some alerts, but there would be a lot of false positives. At least one problem with AWS, one problem with the connection, and our alerts will be like, oh no, we are hacked. And that would just some, I don't know, some fish going through the lines under the sea. We can go with SDLC, which I think is the best and only solution. Like, we can just shift left. So secure development lifecycle. We can secure our continuous integration and development process pipelines. We should discuss before deployment what are the risks, what we need to use, and verify if libraries which we are using and our code which we are deploying is secure. And also implement some verifications on CI/CD that nobody tampered with our code or with some libraries. We can just verify, for example, SHA hashes. I've got also an idea of implementing defensive layers. On AWS, we are able to create something called layers on Lambda functions, which are something like other containers. And there was an idea of implementing a layer which would verify the file system if, for example, nobody tampered with it, or verify the bootstrap or our code. But as long as it is possible, I think that's a lot of work for developers. Like, in case of every function, we'll be needing to implement some defensive things. It will also be probably not so good. It could be also evaded probably. So why to lose time? I'm not seeing a company which will be paying for this method. Like, hey, we want 10 days to implement this layer. And what will be the result? Maybe it would work. Sorry, no. We can also analyze flow logs, so our network traffic. But it's also not so ideal because, yeah, we can see that, for example, our function is connecting to this one IP 10 times a day or million times a day. And that's probably something not good. But we can just create some little botnet and rotate our IP. We can create new machines, so it won't be flagged as some bad ones from VirusTotal or some other companies securing the internet. So I don't see flow logs to be good for this one. And at the end, I wanted to talk a little how we can research these topics. So we've got documentation, especially AWS documentation, which is good. I would say there is a lot of information, but the only problem with AWS documentation is that you won't find anything if you don't know what are you searching for. Like, really, you cannot go to the Lambda documentation and find the information about Firecracker, about the file system and everything, because I don't know why it's hidden somewhere. But if we will search for Firecracker, there's a lot of stuff about it. In case of GCP, I got a lot of problems because documentation is really quiet about backend. We can also search for official events, official blogs. There's also a lot of information. We can just Google it It's that simple. Or we can deploy our Lambda locally, whole code of which is executed on the micro VM. So the bootstrap process, etc., is on the GitHub. It's an open source. And you can also just try it on real environment, because it's not a problem. Oh, that was a GIF, which is not working. Whatever. Because we can just create a function which would be something like a shell over HTTPS. In case of reverse shell, it would cost us billions of dollars, because Lambda is priced based on execution time. So reverse shell is a bad idea. But we can just create an HTTP shell. So we will be sending in HTTP request our commands, and in response, we will be getting the output. And I will try my luck with this one, because I don't have to have VPN connection, probably, to show you how it works. Let's go to some weird folders. Okay, and there should be my shell and my URL. Great, and we've connected to our Lambda. I've implemented something like a shell, and we can just send our commands to get some information about laying file system there. We can also, for example, send the files, like upload it to the Lambda file system. We can download it, so we can just download any file which is on the Lambda file system to analyze it. It's pretty nice stuff. And as I remember, it costed me like $1 after a month. So great thing. I could recommend it. Where is my mouse? Here, great. You can also download it from my GitHub. And yeah, that one is based on Jubals. I've upgraded it a little for my own experimentations. Thank you all for your time. And let's go with some question times.
Basically, I saw your showing class, and it's very common nowadays to have template injection, which is exploiting this class vulnerabilities as well. And when it happens, usually we still keep in this session at the same time. You want to say no? Okay. And then this class will be executed because basic Python stuff happening in there. And we're still able to import Python libraries that will be available there. I don't know, I mean, it will depend on the environment. And still having the same reverse shell or anything using simple template injection techniques. Just adding more content, like really good work like that.
Yeah, thank you.
Great. No questions. Also from online people. Pawel Kusiński.
Kusiński. Nice, nice. You got that.
So great. Thank you.
Thank you also.